So welcome to today's webinar. We're going to talk a lot about how FlexSim can be used within a manufacturing environment to help move from guesswork to a data-informed decision making. So I'll start with understanding industry trends. We'll get into what discrete event simulation is, give you an introduction to FlexSim, and then talk about the ROI and how to get started. So quick introduction on myself. I've been doing simulation modeling for 24 years now. New to Imagine-It, or relatively new. I've been here for 7 months. But I'm also a professor of industrial engineering, where I teach students how to use FlexSim and do simulation modeling. I teach a facility design class, and I teach operations management grad school class. Before Imagine-It, I was the director of manufacturing logistics solutions at ProModel, which is another software simulation tool. And then I led the simulation team at BAE Systems before that. So I have a lot of project experience. This just goes through some projects that I've done, what they were. So I worked a lot in the defense industry, especially at BAE Systems, doing capacity planning and understanding what the organization needed for people, equipment, and space to meet the growing demand for those products. Similarly, I've worked with a motorcycle manufacturing company, looking at facility design, but then also understanding how do they set up the material replenishment process to support that organization and make sure they do not stock out the line. And then another project was with a Navy shipyard, where we developed a scheduling and planning solution that integrated with all of their internal IT systems so that they could significantly reduce their planning time and be able to quickly run what-if scenarios to support future demand. So now I'm going to turn it over to Josh so he can introduce himself.
Hi there, yeah, Josh Stevens. Been using FlexSim in my daily life for the past 8 years. I actually started out at FlexSim, helped with technical consulting a lot there, and also was one of the developers there. So helped out with developing different features in FlexSim that if you guys use FlexSim that you'll become familiar with as well. After working at FlexSim, I hopped over to Tesla, where I helped standardize a lot of their material flow simulations, especially trying to keep as close lockstep with their design team, specifically on the current cybercab that they're building right now. That was one of the main things I worked there. I have about 30 plus projects under my belt. These are just the quick ones to highlight what I've done. Haven't been here much longer than Matt, followed Matt right into Imagine-It, and trying to help everybody out with their FlexSim needs and simulation needs in general. So yes, in the future, if you guys work with us, then I'll be your main go-to for the model support and such.
Thanks, Josh. So some of you that are new to Imagine-It, we just wanted to start with, what our organization does at a high level. And we really help organizations improve their operational excellence, whether it's helping understand and streamlining the processes, understanding what technologies are needed to support and improve that process, leverage our experience. So in FlexSim, it's mine, Josh's, and the other parts of our team's background and experience. And then helping organizations get trained and be prepared to leverage those technologies or those processes to be effective in the organization. So in the manufacturing industry right now, there's a lot of changes that are going on, significant changes that are happening. One of the key ones is that new manufacturing facilities are being built at a record pace. Organizations are redesigning their facilities, or they're building net new facilities to prepare for growth. There's also a major talent shortage where there's currently about 5 million unfilled jobs out there because there's not enough people that are looking for a lot of those manual assembly type operations. And then another big thing is there's a lot of automation going on. And one of the things that we see is people are trying to automate an inefficient process. And a lot of times you need to improve the process and then look at how automation fits in that environment. So with all of these things going on, organizations are trying to figure out, how do I leverage a lot of the data that we have? And most organizations, 80% of their business data is unused. So how can we use that in a smart way to support and improve our decision making? So simulation can help in a lot of different areas. And a lot of people, when they first get introduced to simulation, they think about it from a factory design perspective. If you're building a new facility or if you're redesigning a current facility, you might think that this is where, this might fit. From my experience, most organizations are using it from a strategic perspective and using it for capacity planning, understanding how much equipment will be needed based on certain growth projections, what staffing is required to support that operation, what can we do to improve the operation, whether you're doing Lean or Six Sigma projects, leveraging the models to test what the impact that those decisions will have on the overall operation. So there's multiple other areas. We just wanted to give you a flavor of where we see clients using this and what they're using it for. So manufacturers are changing the way that they are leveraging different tools and looking at not just leveraging current state information, but doing more data analysis, leveraging the data they have so they can not just have a snapshot of a process like a value stream map, they can project what's going to happen in the future. But this is how a lot of organizations are doing analysis now. It's a static environment. It works periodically, but sometimes you're design or change systems and you realize that you forgot to consider something. And that's where the modeling really helps provide a different view and a more detailed view of an organization. So simulation accounts for variability. So in the real world, process times are variable. So it might take 5 minutes one time, 10 minutes another time. There can be risks involved, whether it's quality, defects, machine breakdowns that you want to be able to take into account and understand the impact of them. There's also real world system constraints. So you have limited people, limited equipment, and limited space that you want to consider when you're evaluating the design of a system, or you're looking at improving a system, because you might make a change in a bottleneck area expecting to see a big improvement to the operation, but it may just move that bottleneck down the line. And being able to look at it from a system perspective helps you understand the overall impact of changes. And then we have the interdependencies of an actual system. Understanding how resources and machines work together. how decisions are made from the resources on what do they want to work on next and what is the impact of those decisions. And then it's also evaluating the system over time. So not only understanding if there's constraints, but when you may have constraints in the future based on changes in demand and mix or other changes that you're making within your operation. So what is discrete event simulation at a high level? It's a digital representation of a process. And that process can be back office operation, could be engineering change order process, could be a manufacturing facility, warehouse operation. It can be any process that has a demand going through a sequence of events. And it also helps identify where and when you're going to have bottlenecks within that system. And the main value is it's a what-if sandbox and a risk-free environment to try different options on how you may lay out or design an operation. And then you get to evaluate ideas before implementation. One of the things that we've run into, I'd say the most over the last 7 months, is organizations that have redesigned their operations, started production, and then realized that they have constraints and they need to figure out how to fix them. Something that they should have done before they built the new facility or designed that operation. So when you can do that before you make changes, you save significant time and significant money by being able to do that. And then it's a tool that grows with the organization. I know when I was at BAE Systems for 4 years, I leveraged the same models of the production facilities, and we were evaluating future capacity every 2 to 3 months, looking out 3 to 5 years, depending on the areas we were evaluating. So that tool can grow with the organization. So as you're introducing new products or you're making staffing decisions, you're continually leveraging that support tool. And then it's a communication tool to help people understand what is actually going on in the manufacturing environment, so that you can show this to others, so they can see the impact that decisions are going to have from a visual perspective instead of just looking at numbers on a screen. And a lot of times we have this whack-a-mole picture over here. And the reason we have that is we want to leverage simulation on an ongoing basis. Just because you fix one problem doesn't mean another one is going to pop up. So being able to do the detailed analysis of your different operations will allow you to react to things popping up, or be proactive so they don't pop up in general. And just a note, there are some questions about simulation model that we get a lot, and it is not a physics-based model. So just understand we're looking at it from a process perspective, not a physics-based perspective. So this is just a visual of some different operations. So from warehouse to chemical manufacturing to conveyor systems to people flow at airports, or even fish production. So they're filleting fish, inspecting it, sending it down the line, processing it, and canning it. So the models can be used in a lot of different environments as long as they are process related. And this one looks at, the breakup of a call center and the different paths that people can go down. And then we could look at automation systems and how implementing any type of automation will impact the operation. So value of simulation, there's some standard ROI numbers that are out there. Mostly what we see is looking at CapEx and facility layouts, that if you can avoid significant capital costs, then you have a very large payback on the models that you're doing. I know when I was at BAE Systems, we had several machines that were over $1 million each. And there are several instances where we were able to avoid that expense because we showed that it wasn't needed to support future growth. Sometimes you just need to cross-train people to leverage the equipment that you have available. We also look at savings on staffing. Some of that is through reducing overtime or looking at how to better balance the workload across the team. We also look at inventory reduction or increasing throughput within the organization. Because we're looking at improving the efficiencies, a lot of times we can get more product through the system without having to invest more in personnel or equipment. So there's a lot of ways to save money through the modeling efforts. And one of the things that I've seen over the last 20 years is sometimes the biggest value is forcing an organization to walk through the details of a process. And sometimes through the data collection process, we uncover a lot of low-hanging fruit that people were not aware of that was happening, that we could provide significant improvement just by making some of those changes and seeing what the impact is. But once organizations get started and they start to leverage it more across their operations, you start to uncover more and more issues and more value from the simulation as you go from cells to facilities to looking at your overall network of manufacturing operations. So I wanted to walk through the methodology that we use within simulation. And this is standard across any type of discrete event simulation, is we want to start with digitizing the operation. So taking the products in demand, your process information, equipment, resource requirements, and all of the different business rules that how things move through and how decisions are made within the factory, we can model that and visually see how things are going to behave and where inventory is going to build up within that operation. And we can look at it from a layout perspective, whether it's 2D or 3D like this. We can view it from a process perspective, understanding the detailed sequence of events and where things are getting held up. But we can also view different metrics to visually see the performance of the overall system. So there's lots of ways to visualize what is happening within the operation. So you can then start the analytics process. And then when we analyze the system, there's lots of different ways to evaluate the performance. Typically, we start at a high level and evaluate what is happening to our inventory in the system. Are we getting to a steady state production, or do we have a constraint and inventory is constantly building up? And then we can break it down by different areas of the facility and understand where constraints are happening. We could look at it from a throughput perspective. Are we able to meet our demand? If not, where within the operation are we struggling? Is it assembly? Is it inspection? Is it test? Or is it in a certain named area within your operation? But we also look at throughput over time to understand and see the variation from a process perspective. Do we have a consistent process, or is there significant changes on a day-to-day basis, which may indicate that there's moving bottlenecks through the system? And next, we kind of peel the onion back and look at it from a more detailed perspective. So we might evaluate the utilization of the equipment and break it down into different buckets or states that the machine might be in. So whether it's setup time or downtime or process time, this helps us identify the types of waste or constraints that can exist within the operation. Then we can look at our personnel or our material handling equipment and understand the details of what they're doing on a regular basis. What percentage of time are they doing work? What percent of the time are they traveling? And that helps us understand, is it a capacity issue? Is it a layout issue? Is it a material issue? What are the different causes that could be making the system not behave? And then we have a lot of other reports that we could look at, like travel distance or energy usage, to help us refine our analysis. And then we can make our own metrics within this environment too, if there's anything custom that you want to look at. So our next step is looking at how do we now improve the process that we have. And anything that is an input to the model is changeable. So if it's your demand, how many people you have, how many machines you have, anything that's numerical is easily changeable. But then we may also put switches in there. So we may be evaluating automation or different machines to understand the impact. So we can put switches in and say, for this scenario, we want to turn them on, or another scenario, we may turn them off. And the idea is you want to understand what impact these changes will have. So one of the things you can do is you can create a dashboard for the user where they can make changes, they can turn things on and off, they can select to use different pieces or not. Or there's a scenario manager where you can create your design of experiments. So you may have some of the items that are changeable or the attributes that are changeable across the top. And then your scenarios are going down the left side. So we always have a baseline scenario or current state. Where are we? And then we may say, well, what happens if we want to produce 20% more product? And then if we do that, we might have constraints. And what are the things that we want to evaluate to be able to meet that demand? Do we need to add more people? Do we need to add more machines? Maybe we can do some process improvement to make the process more efficient. Or maybe you have some switches in here that you might add automation or change layouts. Whatever those individual changes are that you want to test, you can create different scenarios and then evaluate those scenarios against each other and really understand what is the quantifiable impact that each of those changes are going to have on the overall system. And does it help you meet your goals of whatever that system is? There is optimization software that you can purchase to add on to FlexSim. But usually within a manufacturing organization, it's a sequential process of identify the constraint, go through and add it. Sometimes it's longer to create your objective function for the simulation to run that optimization, or there's too many options to check. So now we're going to do a quick intro to FlexSim for the people that are new to the software, so you can just get an idea of the interface and how it works. So this is the FlexSim software. If I want to create a new model, I need to specify what do I want my units in. So I'll make it feet, and then my time units will be in minutes. And right away, you're going to see a grid in the layout because it is set to a certain scale. So it knows the distance from one location to another, which helps us understand travel times and other things. So on the left-hand side are our objects that we can bring into the model. Depending on the types of analysis that we're doing. So we have resources, we have things that do tasks, we have conveyors, warehousing, AGV systems, fluid flow, and even people graphics. And to start, we want to tell the system that there's a source of demand. And then we can specify, and we're just dragging objects over to help understand what the process is. Maybe it goes to a queue, and then the sink is where it exits the system. So by dragging in the equipment, we can quickly create a layout. Now, the software will use CAD graphics. So if you have an AutoCAD layout or Inventor layout, we can import that in the background, or we can just start with a basic flow. So once we identify our locations that are going to be used in the operation, I can then drag how these objects are connected to each other. So I'm saying the product is going to go from this queue to this location, and then it's going to go to this queue over here. So that helps us create our basic process flow. Now I want to say I'm just going to have an operator in here. And maybe on the back end, I'll use a robot just to have a graphic in here. So now I want to go through and set up the details of the process. I've put in my constraints, and now I want to look at the process. Let's see. Hide that menu. So for the source, this is demand coming in. I want to specify how often I have product coming in. And that could be a production schedule. You can say something comes in every 10 minutes. Or you can create a sequence or your own production schedule within the environment. Or link to external sources. So if you have a schedule in Excel, you can link directly to Excel and use that as an input. Next, we have our queue. So this is where we specify any capacity constraints. So we may only have space to store 100 products. So maybe we just limit it to 100. And now we need to decide where does it go. So we've said with the process steps in here that it could go to machine A or it can go to machine B. So we need to specify where is it going. And there's a lot of rules on how you can send it to each location. So I'm just going to select round robin, and I'm going to select that I want to use a resource to do that. And I'm just going to say operator 1. So that resource knows that it's responsible for transporting product between the queue and the machines. But these rules are important because you can make decisions based on a lot of different things in the model. You can make it by probability. Maybe 90% of the time you're at an inspection operation and it passes. 10% it fails. Or you may have different product types. So product type A goes to machine 1, product type B goes to machine 2. So lots of ways to define the flow. Now at the machine, we can specify what happens at this machine. How many items can it process at a time? Is there a setup time? We'll just put 1 minute setup time, and we need a resource for that. So we're going to use the resource, and we'll use the operator again. Oh, clicked on the wrong thing. Oh, that's why. There we go. Helps when I actually select him and not the path. All right. So now I have the resource doing the setup time, and then the machine's going to run on its own. So that it runs for 10 minutes. This machine, setup time, it's going to use the operator. Same thing. We'll select operator 1. And now that process is defined. So now we want to say, how does it move from the machine to the queue? So we just say output is going to use the transporter, and now we want to use the robot to move it off that machine. Same thing over here. We're going to select the robot. So now we've built the processing. When it gets done here, it'll exit at the queue. And we can now run the model and look at how the system is going to perform over time. So you see we have a clock up at the top, which is specifying the time and looking at how the system is behaving over time. So periodically we'll see things coming in, and that will change what's happening in the system. And now we have more product coming in, and we can see that both machines are being used, the robot's busy, and periodically we see material building up in the queue over here, just based on the variability of product coming in. So this is a great start, and it allows us to see what is happening in a dynamic environment. And everything that we've built from a process perspective is drag and drop and selecting items within a menu. So it's designed to make it easier to support model building. So visualization is good. And our next step is, well, what if we want to analyze the performance of the system? And one of the things that we can do is from our machines or from our resources, we have the ability to create reports directly from those areas. So if I want to look at the throughput of that item, I can just click on the pin and it'll add it to the report for me. Or I can just create some standard reports. So I may want to look at my work in process, maybe I want to look at my throughput. And then I'll select some pie charts for my resources. And I'll do a bar chart for the equipment. So I'm just selecting the types of reports that I want to use, and there's a lot of them on the left-hand side. And now I want to just specify what do I want to use in those reports. So I want my WIP between when product arrives and when it exits. My throughput, I'm calculating based on the products going through the exit. The objects I want to use to analyze my personnel. I'm just clicking on these droppers to select what do I want to analyze. And then this last one, you can also just select objects and say, I want to use all of my equipment. And it'll just add all of the equipment to the list to simplify it. So now I've created my different reports, and now I can run the model. So now visually, I can see what is going on within the operation. I can see the robot is significantly more utilized than the person. But that person is being utilized about 7.5% of the time, and they're traveling less than 1% of the time. As opposed to the robot, they're traveling 78% of the time, either picking up stuff or dropping it off. And being able to see those different states allows us to understand a little bit more detail on what they're doing. And then from a process perspective, we could see the two machines. We can see their utilization. They're being set up about 4% of the time. This light blue is idle. So they're idle about 26% of the time. And then one of the things that the model allows you to see are things that are hard to identify or quantify in the real world. So this, I'm just going to stop it. So this light purple over here is the percentage of time that the machine has a part that's finished and it's waiting for the transporter. So this machine is shut down and can't be used because it's waiting for the robot to offload it. And that's something you typically wouldn't understand or see in a manufacturing environment. And we can quantify what that is and how it's affecting the operation. So this runs us through the visualize and optimize, or visualize and analyze. So we can then come in and evaluate what the impact would be of adding another robot. So what we can do is create a parameter for the number of robots. And right now the value is 1, but maybe we want to test different things and we want to be able to update the number of robots that are being used. So right now I have 1, but now I want to change it to 2. So in my model, if I reset this model, I now have 2 in here. And I can run and understand what the impact of adding that second resource will be. And now it's automatically added that robot to the reports, and we can see how much are they being used, and does that affect WIP or throughput, and how does that affect the operation. So just a quick walkthrough of FlexSim, talking about ease of use and how it's used. The great thing about it is that it's intuitive, especially for people that are process oriented and can think of the sequence of events that products or items are going through in a system. The other thing is that it's modular, and you can create standard object libraries. You can create some automation. If your organization has standard products, you can create and reuse those objects within the software. And then it's also visual and gives you a good representation of what the actual or future system is going to look like. And that could be 3D. It also has the ability to use VR goggles, so you could walk through what the production operation is going to look like. But the main thing when looking at it, and why we selected FlexSim for my undergraduate simulation class, is that it's intuitive, and code free, and that you can build very detailed models without having to write any code, which is unlike a lot of other software that I've used in the past. But when we look at FlexSim, we also want to understand the bigger picture. The FlexSim software by itself is a very powerful tool and very flexible tool. With Autodesk buying it last year, they've added a lot of additional capability to be able to integrate with AutoCAD, Inventor, and Revit. So AutoCAD typically is your layouts of the floor, but you can also bring in your Inventor graphics if you have images of the equipment within your operation. Or there's other 3D graphics that you can bring in to represent equipment. But then there's also the ability to bring in files from 3D scanning tools like Leica, where you can scan an operation, convert it to AutoCAD and Inventor, and then bring that directly into FlexSim. And I was at a facility 2 weeks ago where we did that with a backpack scanner, where we walked the production line and then had that 3D layout of that operation that we could then leverage within a model. Then we could also do data integration with other data sources. So whether you have an ERP system, a MES system, any information that we want to bring in and leverage, we have the ability to link to those databases or link to Excel or other sources of information. I'm going to turn it over to Josh to talk about scalability and reusability, because this is one of the big things that he focused on when he was at Tesla. Really making things reusable across an organization that are simple and easy to use with some drag and drop, and significantly reduces a lot of the repetitive work that organizations do across their teams. So Josh?
All right, thanks, Matt. As you guys have seen with how Matt was building the model, so I want to go through these different levels. So what Matt was using was just the FlexSim objects. They're awesome. They're drag and drop. They're updated by the FlexSim team. So if there's something wrong with it, or if there's something that needs to be implemented more, the FlexSim team will take care of it. And when you reopen your model, it's ready to go. Drag and drop those right into your model. As Matt demonstrated, a lot of those core FlexSim objects represent, basic equipment, state time of objects within those equipments. How does the equipment send it further on, and such. So those are really great, and you can build great models with just the basic FlexSim objects. There are times, and I'd like to relate that to, say, take like a robot. You have one piece of equipment, robot, that's great. But then what happens when you are reusing multiple robots in cells, and you have multiple of the same cells everywhere, and you're tired of just, selecting all those objects and copying and pasting them, even in copying and pasting them into another model? That's where user libraries come into play. You can actually create a collection of objects in a user library that acts very similar to the other objects in the FlexSim library where you drag and drop. So now when you drag and drop out from the user library, it'll already create your work cell, essentially, placing multiple robots, placing, whatever connections you had between those robots and other FlexSim objects, those are kept. And then you can link that cell to other parts of your model and going forward. So again, you can even do an entire assembly line, add it to your user library, even send that user library to, say, another user, and they can drag and drop it into their model and use it with all the same logic, with the similarities to going forward. So that's where user libraries come into play. FlexSim modules, that's when you want to expand beyond just the capabilities of FlexSim, or there's some core functionality that you're using over and over and over again, and you're sick of copying and pasting it, or you added a lot of really cool logic that you want to have more control over. That's where FlexSim modules come into play. So if you open up FlexSim, FlexSim already is built on modules that the FlexSim team built. So the A-Star, AGV, and many other ones, the People module that's built for healthcare. All of those are actually FlexSim modules. So all you're doing when you're building a FlexSim module is doing the similar things that those things are already doing. You're adding drag and drop objects, custom objects that you build into the user library. You can add custom charts. So you're not telling people how to reuse them or yourself to how to rebuild charts a specific way. Now you can just double click and have a drag out chart that you've designed in the past. You can also go beyond of saying maybe there's some enterprise software that you use, or even some IP that your company has and controls that you don't want to let out, but you want to connect it to FlexSim. That's when you can actually build that connectivity right into FlexSim using a FlexSim module. So it is built in C++. So it is something where if you can write in C++, you can add it into FlexSim. And so that's the big use case for FlexSim modules, is where you have large systems that you can actually simplify into just a single drag and drop that you want to use throughout your model working experience and workflow. Yeah.
All right. Thanks, Josh. Yeah, and kind of the big thing to think about with these types of objects or things that you can build is that they are reusable across the teams, and they can save a significant amount of time. And one of the modules Josh built for Tesla, it moved people from having to take 4 weeks to do a new material flow analysis of the Gigafactory to being able to do it in days. And something that was repeatable, had standardized templates and workflow that really made it easy. So any organization with multiple users or multiple facilities that you're looking at leveraging the tools across is an opportunity to kind of evaluate how you can make things easier and reusable to support your team. So when we're looking at ROI to support projects, we've already talked about some of the value areas to the right, but there's really 4 things that we look at from an ROI perspective. Number 1 is cost savings. So, within your current operations, we might be reducing inventory, downtime, and staffing. There's things that we can do now to save money. Sometimes when you're looking at future facilities and doing capacity planning, those are more of a cost avoidance. So you're making decisions now so you avoid issues in the future, either having too much equipment or not having the right staff. And then there's risk mitigation. So looking at contingency planning, that happens a lot in hospitals, understanding the surge of flu or other things. But sometimes even in manufacturing, you may do some sensitivity analysis around your facility and say, well, this is where we think we're going to be next year. This is our best estimate. But what if it's 10% more or 20% more? Are we going to be able to handle that, or are we going to get stuck? To kind of help plan for potential issues. But it can also improve the sales process. And a lot of the clients that we've been talking to are automation companies that are designing systems for their clients. And those systems need to meet certain requirements. So a lot of organizations now, as part of that bid process, are starting to say, well, you should do a simulation model of that so you can prove how you're going to meet those requirements. Those organizations can leverage the simulation software to help improve that sales process and potentially improve their win rate. Typically, we see an ROI within the first 3 months of an organization, either doing a project or getting trained with the right support. So the payback usually is pretty quick and pretty large. Oh, I think I skipped a slide. Nope. So one of the things that we focus on with organizations is providing the right support for them to get started and to be successful using the software. And what we see is that there's various types of users within an organization. So there's a requirement to have different training to support them. The essentials training really gives people the skill sets to build and analyze different cells. If you're trying to look at building a model of your whole factory or a larger operation, then you might need some intermediate level training in addition to the basics. And that's to help with data integration, developing templates, and doing some of those more detailed design work. And then very rarely, but sometimes you need an expert level user within your organization. So maybe someone's building reusable applications to support multiple different facilities, or they want to create custom GUIs. So that expert level training will help someone develop those skills and to be able to do the coding that's required to get to that level. But we also have leadership training. And the reason we have that is we want the stakeholders within the organization to understand what the value of simulation is, what are the business cases that it can support, and how do they quantify ROI for the engagements. That way you're getting, the push up from the simulation users from below, but you're also getting the support from the leadership team. And that's just a quick training to really introduce them to the software and the capabilities. So beyond training, what we found to make organizations be successful is having mentoring and support available for the first 2 to 3 projects as someone gets up the learning curve. And with that, we look at a plan of starting with a small project and ramping up the capabilities as a person does more projects. So that's something that we would leverage Josh for to help you, have him available to support your projects and answer any questions you have, to reduce any struggling that you have, answer questions quickly, and help you get to value with the software faster. So beyond training, we also have a lot of other services and things that we do to support simulation and modeling. So whether it's advisory services, understanding what's going on, within the industry, doing assessments on the organization. Are you ready? Do you have the right data? What is, the possible scope for a project or cost to do a project? Or even doing pilot projects. So maybe you want to start with a small cell and something we can build within a few days. And that kind of helps guide you in your decision making. We also do software development, so we can build a lot of that reusable capability that Josh talked about to help organizations be more agile with their projects. But then we also do projects from beginning to end. So if you have a project, you don't have the people or the time to get it done, then we can come in and do that project for you. Or even develop reusable applications that your team can use to answer questions along the way. And sometimes a solution for an organization might be a combination of these things. And that's where we really kind of step back and understand the organization goals, what you're trying to accomplish, so we can provide a holistic approach to help you and your organization be successful.